webinar about HMI SCADA redundancy. My name is Fabio Teresino, and I'll be conducting this webinar today. We will send a copy of this PowerPoint presentation as well as the sample application used during the webinar to all the participants in this webinar, so do not worry too much about taking notes. And we'll post this video on the website in a few days. Moreover, the presentation should take something between 30 and 45 minutes. So after the regular presentation, I will open for questions and answers. So in the meantime, if you have any questions, feel free to write them in the chat panel from the webinar or in the Q&A box from the webinar as well. So getting started here, when you talk about availability, it's all about availability and reliability for your system or critical components from your system. And it could be anything from physical networks, controllers, HMI SCADA system, thin clients, databases. So specifically when you talk about the HMI SCADA system, there are at least 5 different interfaces in the Software Studio where redundancy is fully supported. Web thin clients, secure viewer thin clients, history databases, controllers, redundant PLCs, for example, and the main HMI stations, the main HMI SCADA server stations. And it pretty much covers all the typical scenarios in industrial automation projects where you have HMI SCADA systems in some kind of redundant mode. And they are not mutually exclusive, and they do not depend on each other. So you could have a project with all those redundant interfaces, or just a few of them, or just one of them. It really depends on which components from your system are really critical and what level of redundancy you want to incorporate into your project. Again, using those built-in features from InduSoft Studio, you can increase the availability and reliability of your system. So first, talking about the web thin clients, this is the basic scenario. You have 2 server stations. Here I call them the primary server and the secondary server. So you have InduSoft Studio running pretty much the same application on both stations. So the web thin client by default connects to the primary station. However, in InduSoft, you have the ability to configure the IP address of the secondary server and the URL for the secondary server in this dialog from Project Web Thin Clients Advanced. So when you do that, the web thin client connects to the primary, but if the primary becomes unavailable for any reason, the web thin client automatically switches to the secondary and then remains connected to the secondary until you either disconnect, close the web thin client, or if the secondary server becomes unavailable for whatever reason. In this case, the web thin client will try to connect again with the primary server. And this switch from the primary to the secondary or from the secondary to the primary is done automatically and virtually with in a transparent way for the user, for the web thin client user. So on the development environment of InduSoft Studio, you can go to Project, Thin Clients, Advanced, and here you just type of the secondary server where InduSoft Studio is running, and the URL for the screen for the web files on the secondary server. And those settings will be used by the web thin client to switch from the primary to the secondary during the runtime if the primary becomes unavailable. You can either hard code those values here, the secondary data server IP address and the URL, which is typically the case in a specific project if you know the IP addresses and if they are not supposed to change over time. or you can set them dynamically during the runtime using this built-in function called setWebConfig. So in this function setWebConfig, you can define the IP address of the primary server, the URL for the secondary server, the path where you have the ADTML files for your application and which files, in this case just the startup file .adtml, so which ADTML files should be updated. The TCPIP port for connection, I'm using the default 1234, and the IP address for the secondary server. So when I call this function, InduSoft automatically updates the ADTML files or file that you identify here, that you specify here, with those settings: the primary IP address, the URL for the secondary server, the TCP port connection, and the IP address for the secondary server. This way, you don't have to hard code this information in this dialog. So if you want to deploy the same project in different systems with different IP addresses, you can call this function and change those settings dynamically. And in this case, I'm using tags here for the secondary primary IP address, secondary IP address, and secondary URL. And those tags I load from a recipe when I start the project. So when I start the project, I load in those tags the IP address of the primary server and the IP address for the secondary server. And then I use those tags in this function to set the ADTML page with the primary IP address and secondary IP address. One way is not necessarily better than the other. Using the setWebConfig function, you can change the settings just by changing a recipe file, an XML file, or text file. But if you know the IP addresses and they are fixed, it's just easier to use the built-in GUI here and type here the secondary server IP address and the backup URL. So let's see how it works during the runtime. Do not worry too much about the indications here. We'll talk about these in details later. Here is where I configure the primary server IP and the secondary server IP. So when I click apply, I save those settings into the recipe, and when I run the application, I load those settings from the recipe and save this information on the ADTML page as well. So I have two servers. This local one on the IP address 10.168.23.135 is what I call the primary server, and the secondary server is running on the IP address 10.168.23.190. And as you see here, with a remote desktop connection, I can see my secondary server here. So I can even stop my secondary server on the remote desktop connection. So my primary one identifies that the secondary is off, or I can run the application on the secondary server as well. And it's exactly the same application. So I have my primary server, my secondary server. If I launch the WebSync client, it tries to connect with the primary server by default. So it's downloading the pages here. I see the application on the browser, and it is connected with the primary server. If for any reason I stop the primary server, so I'm going to stop the application here on the server, the thin client disconnects from the primary and automatically connects to the secondary server. So as you see some question marks for maybe 1 second here, and then the thin client automatically reconnects with the secondary server. And I show here that the primary server is offline because the application is no longer running. I can run the application on the server again. And the WebSync client shows here that the primary server is running, but it remains connected with the secondary server. If I go to the secondary server using here my remote desktop connection and stop the application on the secondary server, then my WebSync client switches from the secondary server back to the primary server. So as you see, just by setting the IP address of the primary server and the IP address in URL for the secondary server, the WebSync clients automatically switch back and forth between the primary server and the secondary server. So it's a very simple configuration and works for as many WebSync clients as you have in your network. And again, the only two settings that you really have to configure are the secondary data server IP address and the backup URL. The same feature is available for secure viewer thin clients as well. The only difference is instead of using the development environment and configuring the secondary server IP address on the application settings, you go to the computer where you installed the secure viewer thin client, and you run here the secure viewer configuration interface. And in this interface, you configure the IP address and the URL for this primary server. And in advanced, you type the IP address and the URL for the secondary server, just like displayed here in this screenshot. So the secure viewer will behave just like the WebSync client. It will connect to the primary server, but if for any reason the primary server goes down, it switches automatically to the secondary server and vice versa. So same behavior as the WebSync client is available as well for the secure viewer thin client. Before we talk about HMI configuration and other type of redundant systems, in some cases you want to use redundant data. This is a quite extensive subject, so we had another webinar talking only about database redundancy, and you can watch the video about the webinar we did a few weeks ago about database redundancy. But here I would like to recap at least the basics about database redundancy. So in InduSoft, you have the ability to save and retrieve data from any SQL relational database. Could be Microsoft SQL Server, Oracle, Sybase, MySQL, simple Microsoft Access files, any database that you can connect to using ODBC, OLIDB, ADO, or ADO.NET. And the nice thing is InduSoft provides a user-friendly interface to configure the link with the databases, so you do not have to know SQL or write complex code scripts to connect to the databases. And then there are two modes of redundancy, database redundancy, supported by InduSoft Web Studio. One is called redundant. The second one is called store and forward. In the redundant mode, InduSoft saves data in both databases, into the primary and the secondary database, simultaneously. So all the data is saved in both databases. If any database, doesn't matter which one, if any database becomes unavailable, InduSoft keeps saving data into the remaining one. And when the other database becomes available again, InduSoft automatically synchronizes the information between both databases and keeps saving data in both databases. So it's done automatically for you. In store and forward mode, InduSoft saves data only to the primary, not to the secondary. If the primary becomes unavailable, and only if the primary becomes unavailable, then InduSoft starts saving data into the secondary database. And when the primary database becomes available again, InduSoft moves the data, does not primary database, and then keeps saving data into the primary database. And this is a very typical configuration when the primary database is in a remote station, but you want to make sure that you do not lose history data if the connection with the remote database is lost. So in this case, InduSoft saves data into a local database. Typically, the secondary database is a local one. And when the primary database becomes available again, we move the data from the secondary to the primary. A backup to keep data locally only while the primary database is not available for whatever reason. And from the configuration point of view, you can go to Project Options. Here in the default database configuration, here you configure pretty much the link with the primary database. It could be SQL Server, Oracle, any type. And here in secondary, you define the mode of the secondary database, either redundant or store and forward, and build here the connection for the secondary database as well. And again, we did another webinar a few weeks ago about database redundancy, and you can access this webinar from the InduSoft website. So if you go here to InduSoft.com, under Support, Example Videos, we have here a link to watch the video about database connectivity and database redundancy. Other type of redundancy that you typically see in industrial automation projects is PLC redundancy. Controller or RTU, more generically speaking, but typically PLC's redundancy. So in InduSoft, we have a very simple way to configure InduSoft to talk to the primary PLC. But if the primary PLC goes off for any reason, InduSoft automatically switches to the second PLC, to the second controller. And the way we do that is in the driver worksheets from InduSoft, either the main driver sheet or the standard driver sheet, the field station where you define the address of the PLC, you can use a string tag between curly braces in these fields. So just by changing the value of this string tag, InduSoft switches from one PLC to any other one. So on the configuration here, we have redundancy.current PLC station. So by changing the value of this tag, I switch from the PLC, from the primary PLC to the secondary PLC and vice versa. I could hard code the IP address, the station for those PLCs, but to make it more generic, in my recipe, I'm saving the IP address of the primary PLC and secondary PLC as well. So even during the runtime, I can click here and type here, configure in this tag the station address for my primary PLC and the IP address, the station field for my secondary PLC. So how to switch from one PLC to the other? This is the basic algorithm. And this is just a suggestion. In InduSoft, you have the flexibility to implement whatever algorithm you want to switch from the primary to the secondary. But typically, you check, is the communication okay? And in the driver worksheet, you can have a tag here in the read status field. If this tag has the value 0, it means the communication is okay. Otherwise, you have a communication error. So if the communication is okay, you do nothing. You remain connected to the PLC you are talking to. If the communication is not okay, then we check for how long the communication is not okay. And that's why we define this setting here called timeout. So it's important to have this timeout. So if you have a communication error for any reason that is not a PLC failure, like a noise in the network, one timeout that is recovered automatically, something like that, you do not switch automatically to the secondary PLC. So we check if the communication is not okay, and it's not okay for at least X seconds, which is configurable, and you have tried to communicate with this current PLC for at least X seconds, then switch to the other PLC. otherwise remain in the PLC you are. And here you see an example code to implement what I just described. So here in this project, if I go to this script, controller PLC redundancy, I set this variable here, PLC timeout delay, with the value of this tag that I read from the recipe. And let me hide those panels so I have more space to show the rest of the script. And then I check the communication status. If the communication status is 0, I jump to the end. So I do nothing, pretty much. If the communication status is different from 0, and this is the tag I used here in the read status field from my driver worksheet. So if I have a communication error, then I check here in this tag the time difference in seconds between now and the last time that the status changed of value. So how long ago the status went from good to bad. And in this tag, I check how long ago I switched from one PLC to the other. If both times are greater than the timeout that I configured, then I swap the PLCs. I switch from the hot PLC to the primary, or from the primary to the secondary. Let's see how it works during the runtime. So as you can see here, the current PLC station is the first one. So I'm connected to the PLC. I see the PLC values here. They are all 0. I'm going to use a switch here in my lab to turn off the first PLC. So InduSoft identifies that the PLC is off, and you see here question marks. And within 3 seconds, it switches to the secondary PLC, which is online here. So now InduSoft is talking to the secondary PLC. And I turned the primary PLC back on, but InduSoft remains communicating with the secondary PLC. So if I switch off the secondary PLC, InduSoft identifies a communication error, and if it does not recover within 3 seconds, it switches back to the primary PLC. So it's a very simple algorithm, but for 2 or more PLCs, just by changing the tag configured in the station field from the driver worksheet. So you do not have to create 2 driver worksheets, one for each PLC. You just create one, and by changing this tag value, you swap from one PLC to the other. Finally, we can discuss the last level of redundancy, which is typically called HMI SCADA server redundancy. And just to discuss the nomenclature up front, I wrote here the concept for station, mode, and status. So in a hot standby system, I have 2 stations, and here in my script and in the presentation, I call one of them the primary and the other the secondary. Doesn't mean that the primary is the hot station and the secondary is the standby, or vice versa. Either one could be either hot or standby during the runtime, depending on the conditions of the system. But one station is called the primary one, the second one is the secondary. During the runtime, only one station is the hot, and the other one will be the standby if it is still running. The hot station is the one communicating with the PLCs, saving data to the history databases, and the standby station receives tag values from the hot station by exception. So only the hot station brings data from the PLCs, pulls data from the PLCs, and updates the standby station by exception, only when tags change of values. So by this way, you optimize the traffic in the network, and you can communicate with the PLCs using a smaller bandwidth in the network. And the status is another concept here. One station needs to know the status of the other station. And the other station can be either live, if it's running, off, if it is not accessible, or unknown. And unknown is typically a state when you start the application and you still don't know if the remote station is live or off. And after a timeout time, you will know for sure if the remote station is either live or off. So how to find out if the remote station is live or off? With a simple heartbeat algorithm between the primary station and the secondary station. So for instance, in the primary station, I create here a tag called primary heartbeat, and I set in a script, I write the value 0 to this tag continuously. So in the primary station, I reset this tag all the time. In using the TCPIP server from the primary station, I send the value from this primary heartbeat to the secondary station. In the secondary station, using the scheduler, for example, I increment the primary heartbeat every second. And I receive the primary heartbeat from the primary station using the TCPIP client worksheet. So if the primary heartbeat is greater than the timeout, it means that it is incrementing here in this station, and the primary server is not resetting this tag. So the primary server, the secondary server concludes that the primary server is heartbeat changes to 0. It means that the primary server changes this tag to 0. So the secondary station concludes that the primary server is live. You do exactly the same algorithm on the other station for the secondary heartbeat, and then the primary server knows if the secondary server is either off or live. Just to show how to configure that, here on the configuration interface, I can go here to the scheduler, and in the primary station, I keep increasing the secondary heartbeat. And in the secondary station, I keep increasing the primary heartbeat. And in a simple script here, in the primary station, I reset the primary heartbeat. And in the secondary station, I reset the secondary heartbeat. So this whole algorithm here is pretty much summarized in this script with the scheduler. Now, how to set one station to hot or standby? Pretty much, we check if the remote station is off. If the remote station is off, then this local station should be set to hot. So it should enable the communication driver on the fly and enable the ability to save data to the history databases. If the remote station is not off, we check if it is live. If it is not live, it is what we call the unknown state, and we keep the local station in standby. But if the remote station is off, is not off, is live, then I check if the remote station is in standby. If the remote station is in standby, then I set the local one to hot. Otherwise, I set the one to standby. And this is one example of script that executes just what we described. So I check here if this station is the primary station. If it is the primary station, I reset the heartbeat. I set my local station to live, so it's not off. I check if the remote station is off, seeing if the heartbeat is greater than the timeout. I check if the remote station is live, checking if the heartbeat went to 0. And here in this final portion, I check if the second station is off, or if it's live and in standby mode, I set my primary station to hot. Otherwise, I set it to standby. And I use those tags here, is hot and is standby, to enable or disable driver worksheets, trained worksheets, anything that I might want to enable or disable according to the modes of the station, either hot or standby. And let's see how it works during the runtime. So this is my primary server. It's here in standby mode, and it's live. And the secondary server is live as well, and in hot station, in hot mode. So if I switch here to the remote desktop, here I see my secondary server in hot mode. So if I stop the application on the secondary server, are you sure you want to exit? Yes. Then my primary server detects that the secondary server went off and sets this station to the hot mode automatically. Even if I start the application on the secondary server, the primary one remains as the hot one, and the second one starts as the standby station. So now they are both live. The primary one is the hot, the secondary station is the standby. If I stop the application on the primary, then the secondary identifies that the primary server is off and sets itself to hot automatically. And then if I start the application again on the primary, it comes back on as standby. So this thing allows you to implement a hot standby configuration, and clicking on this button, you can define here the IP address of the primary server, IP address of the secondary server, and the timeout. So how long, for instance, in this case, 3 seconds. If one station does not hear the heartbeat from the other station for more than 3 seconds, then it assumes that the other station is off and then sets the current station to standby. One of the main advantages of this solution is that, number one, it's fully configurable, very flexible. You can change the IP addresses on the fly, you can change the timeout on the fly, and by changing the script, you can even change the condition to define that one station is hot or standby. So this is just an example that is very much suitable for the vast majority of the hot standby systems, but you have the flexibility to change this script, to change this algorithm, to change the settings, and define different ways to define one station as hot or standby according to your architecture. And even though hot standby is a very typical architecture, in some projects you need more than 2 stations. You need 3, 4, 5. You need what we call a cascading system. In using the same type of script, the same kind of algorithm, you can create what we call a cascading redundancy. So if any station goes down, the remaining ones take over the actions, the duties from the other stations. And only the hot station keeps reading data from the PLC. So in this case, only the secondary server is pulling data from the PLC. And the hot station keeps updating the primary server, the primary station, via TCPIP. So I have 3 TCPIP client worksheets in this project. I have one used disabled on the primary. So it runs only on the secondary, reading the heartbeat from the primary. I have another one that is disabled on the secondary, runs only on the primary, reading the heartbeat from the secondary. And a third one where you can type your process tags. So whatever station is the standby enables this worksheet and communicates with the remote station, with the hot station, to bring tag values. And if you check this checkbox, send fields, the hot station updates the standby station not only with tag values, but also alarm status, high limits, high limits, low limits, low limits, When you acknowledge the alarm in any station, the other station is updated. So both stations are automatically synchronized during the runtime. And another main advantage of this solution is the way those scripts were written. The same VAR application runs on both stations, on the primary station and on the secondary station. You do not have to create two different applications. The same application can be deployed on both computers, and during the runtime, when I start the application, here in the startup script, I call this function called init redundancy, and in this function, I load the IP address for the primary and secondary from the recipe, and then I check if my computer IP, my local computer IP, is equal to the server IP, then I am the primary. Otherwise, I am the secondary. So by doing that, the same VAR application can run on both stations, and you do not have to manage two different applications. So with that, we conclude the main topics we'd like to cover in this webinar, and I'm going to open for questions. If you have any questions, please feel free to write them in the chat box from the webinar or in the Q&A box from WebEx as well. Okay, so there is one question here about the TCPIP client worksheet, how you can configure the tags from InduSoft in the TCPIP client worksheet. If you come here to project tags, you can pretty much copy all the tags from your project except the tag redundancy and paste them in the third TCPIP client worksheet. So all the tags from your application will be synchronized between the primary and the secondary station. And even if they are classes or arrays, you do not have to worry because InduSoft automatically maps all the classes, members, and array indexes from the primary to the secondary. And assuming that the application is the same on both stations, you do not have to fill the remote tag column because InduSoft assumes that the remote tag has the same name as the primary tag. There is another question here. If there are links for this webinar and the cloud webinar, the actual video, not the PowerPoint slides, yes. If you go to the InduSoft website, here under support, example videos, we post here links for all the webinars we are conducting bi-weekly. So here you have the link to the cloud webinar, here to the database redundancy webinar, and in a few days, this webinar will be available to be watched from this link as well, from this web page, from the InduSoft's website as well. So let me see any other questions. Oh, one question is how to update if I have redundant stations and I make changes in one station, how to update the second one. There are actually three different ways to do that. Either you make the changes in one station, let's say in the primary station, and you manually copy the project folder from the primary station and paste into the secondary or vice versa. Or you can create, for instance, a batch file, and when you double click on the batch file, you pretty much copy the whole project folder from the local station to the remote station. Or the third way would be in the remote station, you can run the remote agent. And in the local station, you go to connect, type here the IP address of the remote station, hit connect, and if you go to project, you can click on download to download the changes from this local station to the remote station. So they are both synchronized. So either manually or using those built-in tools, you can update the application in the local station and the remote station. Obviously important while you are developing the project, but when you are done, then you just keep the same application in both stations. Are the tags redundancy is hot, redundancy is primary, etc., user-defined, or they are system tags? They are user-defined. I created those tags here in my application. And I created here one tag called redundancy from this class. So it is, it's not, they are not system tags. They are user-defined. In this whole application for redundancy, we used here 24 members in this class. So those are project tags that you can create, you can modify, you can even customize if you want to implement a different redundant algorithm. But if you want to use the algorithm that we illustrated here, all you have to do is pretty much copy this tag from this example application to your project, as well as the scripts, and just use the generic scripts and tags that we created in this example. And this example application will be available in the next InduSoft DVD room, and it will be available to download from our website in a few days. We have a few other questions here. Is there PDF document that explains today's topic? In the help from the product, we have some information about that, but the PowerPoint presentation I used today, along with this example application, will be made available to you, so you can use it as an example and as a documentation to implement redundancy within the Software Studio. Another question, is redundancy also available in earlier versions of the product? The HMI redundancy is available for many, many years. I'd say since version 1.0, we could do most of the HMI redundancy, as well as the PLC redundancy. The database redundancy and the thin clients redundancy are available for about 3 or 4 years when we implemented those features in the product. Another question, do you need an InduSoft license for each server? If you see in this architecture here, you have 2 servers, and each one of them is fully self-sufficient. So if the other server goes down, the remaining one has the ability to handle the whole application. So in this case, all you need are 2 licenses, identical licenses, and you install 1 license in each server. They could be either hard keys or soft keys, and each license must be able to handle the whole project, each one of the 2 licenses. What's the minimum timeout to change the primary to secondary? Because in the example, it's 3 seconds. Very good question. And it really depends, and that's why it's configurable. There is always a trade-off between having a very small timeout, which is good because the switch is made pretty fast. On the other hand, if the timeout is too small, one station might conclude that the other one is off when it's not off. It's just because you had some delay on the network. On the other hand, if you set the timeout too high, then you make sure that if you conclude that the other station is off, it's really off, hot, and during this period, you do not read information from the PLCs. So there is a trade-off there, but I can say that in typical applications where you have a local network, a control network, anything from 1 to 3 seconds seems to be reasonable and seems to be good enough to avoid false switches and also to switch within a couple of seconds so you do not lose important data if the hot station goes. Is there any issues with users for security when using a redundant server? No, the security system can be independent for each one of the servers. And even though I didn't cover in this webinar, because we're going to have another webinar only for security system, here in security, you can set one of those stations as the server and the other station as the distributed client, and you just have to type here the IP address of the primary server. And in this way, you have a redundant security system as well. And if you create users in any station or change passwords in any station, both stations are automatically synchronized. Are there any differences between 6.1 and 7.0 regarding redundancy? No. Although the features that we presented here are available in 6.1 Spec 6 as well as in version 7.0. Is this redundancy example available to for download? Not yet, but everybody that attended this webinar will receive the link to download this application by email, and it will be available for everybody at the InduSoft website within a few days. There is one question here about symbol libraries. It's not really about redundancy, but just really quick. In addition to the library of symbols from InduSoft, which is built in here on the development environment, and by the way, every time we release a new service pack, a new version, we keep improving and enhancing this library of symbols. So you'll see some new symbols here available in the most current version of the product. But anyway, InduSoft keeps improving this library of symbols. And if you want to use external libraries like Symbol Factory, for example, that you can purchase from softwaretoolbox.com, or any other library of symbols with pictures or even with ActiveX controls or .NET controls, you can incorporate them very easily within the Software Studio. When a user is able to change the user database during the runtime, I think that's a question about the security system. And yes, using built-in functions like set password, create user, remove user, which are built-in functions from InduSoft, you can change the security system, the user database on the fly. And if you're asking about the redundant database configuration, the answer is yes as well. Because when you go to the database configuration, where you define the connection string, you can either hard code it, or you can write a string tag between curly braces in this field, and by changing the value of this tag, you change the connection string to the databases on the fly. If InduSoft Web Studio internal is used, will the database be updated when failed unit is up and running again? If you're using the InduSoft, I believe the question is about the proprietary databases. You can use redundancy for the proprietary databases as well, instead of using SQL relational databases. But in this case, you have the redundant mode only. You do not have the store and forward. The store and forward mode is fully supported when you save history information to SQL relational databases, SQL Server, Oracle, Sybase, MySQL, and others. So there is another question here. Someone was late on how to configure the thin client for hot and redundant server. We covered that at the beginning of the webinar, but really quickly, you go here to Project, Thin Clients, go to Advanced, and type here the IP address of the secondary server and the URL for the secondary server. And on the fly, the thin clients switch from the primary to the secondary automatically, if the primary becomes unavailable. Another one. No, this is the same question. So I believe it covers all the questions. I'd like to finish here just thanking everybody. Thank you very much for your time, for spending the time here on the webinar. We appreciate your participation and your questions, and I expect to see you again in the next InduSoft webinar. Thank you, everybody, and have a great day.